Yeah, we did 16 questions. So welcome everyone. It's good to have you here. We're going to be doing the hard questions, but before that, maybe we'll skim over some theory. And I say skim because I think you probably already know this, at least from the quiz results. Maybe I can start sharing this. Here we go. Now, hi. Let's discuss some theory. So, more generally, we want to talk about systems of equations to variables. I just want to give a brief overview of some objects we'll be dealing with. So we have something that's called a quadratic function or a degree 2 function. It always has this form, ax squared plus bx plus c. Simplest example of a quadratic function is x squared. So x squared is just ax squared plus bx plus c, but a is 1, b is 0, and c is 0. So that's a good way to think about it. Now, historically, we already know that mathematicians have been really interested in finding roots of equations, especially quadratic equations. What is a root? First off, it is the value which I plug inside of f of x to get 0. So a root is a value I plug into the function to get 0. So for example, if I have a function like x squared, then which x gives me the 0? Not a trick question. So I'm asking which value of x, or maybe which x naught will give a 0. It's 0, right? 0 is the only number which you multiply by itself to get 0. So that is the simplest example of a root of, let's say, a simple quadratic function or a degree 2 function. Now, the experts tell us that there is a way to describe all the roots of the quadratic function, which means all the values at which the function is equal to 0. And it is this. Now, you've probably seen this before. This is the quadratic formula. People just usually give it to you. You usually have to memorize it. I even heard there are some songs for it. Have you heard of it? Yeah, like some people sing songs and they don't learn the theory, which I think very sucks a lot. So if you're not convinced with this, I would probably just give you a brief walkthrough as to why this is true. So I'll start with this statement, and with each step, I'll apply simple operations. So I'll multiply by a number, add number, or subtract one, for example. And so the first thing I would do here, this is the exact same expression. And what I would like to do is multiply by 2a on both sides. I don't know if you see this now. So I'm right here. And multiply by 2a. Hi. And then I just get, this goes to the other side, and this cancels out. So I just get the upper part, I get the numerator. And then I do another thing. And that is, I just add b to both sides. And if I add b to both sides, then this goes there. Hopefully it's not too complicated. I just multiply by 2a and I add b. And then I square both sides. So if this is equal to this, then squaring this should be equal to squaring that. When I do this, I get the square here. This is, of course, apparent in the lower case. And here I have a square as well. Now the square cancels out with the square root. And it also cancels out the positive or negative part. Because if you take the negative square root and you square it, then the minus is multiplied twice and it goes away. Now I can expand this. So I would get this thing squared plus this thing squared. That's here and that's there. Then twice of the first term and second term. You would like me to scroll upward?
Yeah, no, like I couldn't see.
So which part?
The down.
You'd like me to do like this? Yes.
That's what?
So we're trying to make sense of the quadratic formula. We said that historically in school they give you a song where they tell you to memorize it. That's not so fun.
Yeah.
So maybe this is not
That's proof that
fun,
we can.
either, but
The proof that we can
yeah. So we're proving that this is a root to the quadratic equation.
Okay.
It is a proof. I don't want to say proof because people usually get scared. So please,
Okay.
somebody asks you, don't say anything. So when I square those and I expand this, I get this expression. This is squared, this is squared, this is squared. So 4a squared x naught squared, b squared, and then twice of the first term and the second term. So 2 times 2a x naught times b, which is the term in the middle. You can verify this yourself. I hope that's not too much. So just expand it and simplify it. Now notice that we have b squared on both sides, so maybe we should cancel that out. I think that would be nice. By the way, let me know if you cannot see because I'm standing behind the writing. That would suck if you really cannot see. So when I do this, the b squareds cancel out, and then I have this expression. I'll even add 4ac to both sides as well, because why not? So I've added the whole term to the other side. So this will cancel out and it will become positive on the left. And then the final step is to divide by, or to multiply by 1 over 4a. Then the 4 cancels out. The a's cancel out. And I get ax squared plus bx plus c is equal to 0. I think that's nice. And the only reason why this works is because a is not equal to 0. If we divide by 0, then it's a problem. We need to be careful. Which is why when we write this down, we say that a is not equal to 0. So that's just something. If you're not interested, you can just pretend that you didn't hear anything for the last 5 minutes. But this is just a brief walkthrough. And at least some convincing, because you are all adult people. And I don't want to be just fooling you by saying, hey, this is true. And that's it. So this is the quadratic formula. Here we have an example. And I would like you to compute the roots. This is an exercise for you now. you find the roots of this function. And because this is the very first example, I'll just give a hint. Just a hint, or two, or three, or four. You could, of course, do it without the quadratic formula, but it's a good exercise to do it with it. So the first thing I'll do is I'll write down values for A, B, and C. I know that any quadratic equation function has this form, and so in this case A would be 1, B would be 3, and C would be 4, just by comparison. Then I find my roots. Roots for this function. So for B, I put in 3. For A, I put in 1. Oops. And for C, I put in 4.
Complex.
Okay, that's a problem, right? I should have chosen another example, which is going to be the following example. Yeah, so never mind. Just a minor error on my side.
Can't we get a complex root also?
This is just
Not true.
what is it? You will. Let's give me a moment. So if C is -4, then I just put this in here. I think you already see what the problem was. The problem is you got a minus in the square root. That's problematic. We'll talk about this in a moment. So if I try to simplify this, I get -3/2 plus the square root of 3 squared, which is 9. Then 4 times -4 is 16. So minus -16 plus 16. Now 9 plus 16 is 25. And the square root of 25 is 5. But this is plus or minus. So this is very important. Don't forget the plus or minus. So this will give us, one time it will give us 3 plus 5 over 2. So 4. And then the other time will give us, yes, so -3 minus, yes, 4 yes. So -3, yeah, -3 plus 5 over 2, and then -3 minus 5. So maybe I should write them up. So this is 2, and this is -8. So I get 1 and -4. This is what you got as well?
I didn't do it.
Oh, it's fine. But yes, the 1 and -4 should be your roots. So that's something. It's a good exercise. A quadratic equation looks like this. this shape is usually called a parabola. Parabola is just something that looks like a U. It's a U-shaped thing. That's all that is. Just a U-shaped thing. And we can turn this root finding task into a graphical task, which is good if you like Desmos, like some people. And it would make sense if you take a look at this. So when the graph intersects the x-axis, the height of fx is 0. And so the x point at which the graph intercepts the x-axis is the root, because at this very specific x coordinate, your function is equal to 0, its height at least. So that's why we look at intersections of the x-axis. Now, with the parabola shape, the U shape, this will give us 3 cases. I hope you can see them. Maybe I should go a little bit lower. No, I think it's fine, but you should still be able to see it.
Yeah.
So if you have a U shape, then it will either not intersect at all, or it would intersect perfectly, exactly once, or it would intersect 2 times. And this is what we cover in these 3 cases. So this is the graph of x squared plus 1, doesn't intersect. And if you think about this for a moment, this should be true. So there should be no x such that x squared plus 1 is equal to 0. Because if you multiply a negative number by a negative number, you get a positive number. And so this will actually always be greater than 1 or equal to 1. You can't really go any lower than that. If you think about positive values and zeros. And now here, this is perfectly suitable. So x is equal to 0 is the root, because it intersects perfectly at the x-axis. And you could also have the case where the u branches twice. If you just move it 1 step downwards. So you get 2 solutions. Here we have 2 solutions. Let me even show this to you if you're not convinced. Why not? We have x squared plus 3x minus 4. So it intersects twice, precisely at the 2 points we just found. And it turns out that we can actually link this to the square root. If we take a look at this example and we try to find the roots, maybe that could be an exercise for you. You would find that this example, at least for this example, we have exactly 1 root. Okay, maybe it's a good idea to check this. Would you like to check this now? My question is, would you like to check that this function has exactly 1 root?
السؤال انت اصلا نسيتها السؤال
So I've done some progress here. 1 minute, you need 1 minute. So what I've done here is I've compared the coefficients. So A is equal to 1, B is equal to 4, and C is equal to 4. And I plug in the values. Is this plugging in okay? So 4 times 4 times 1 is 16. 4 squared is 16. So that's amazing because this cancels out.
So it's gonna be minus 4 over plus minus 0.
Plus or minus 0.
Over 2.
So that is really the key word. Plus or minus 0. We know that if we add or subtract 0, we always get the same value. So this is the case where you know, okay, I have exactly 1 root, or I have exactly 1 intercept with the x-axis. So that is a good way to test this, let's say, this hypothesis. Now, if you don't believe this, then I invite you to take a look at the red graph. This is the graph of x squared plus 4x plus 4. And it intersects the x-axis just perfectly at the point which we found, which is minus 2. So we've established that the root is indeed minus 2. And it is the only point at which it touches the x-axis. Coincidentally, it is also the case where this part, the square root, is equal to 0. See? I mean, this is going to be 0 if the square is 0, because 0 is the only number whose square gives you 0. So I can just say that if the inside part is 0, then the outside part will be equal to 0. So this can actually be a test for me. So when I have this b squared minus 4ac equal to 0, then I can say I have 1 solution. If I have this b squared minus 4ac greater than 0, then we have 2 solutions. And if we have it less, then there's absolutely no solution. So for the case of 1 solution, we had this. We still need to say something about the other 2 cases, and then we're good to go. So remember, this is the expression we were dealing with originally. When would we not get a solution? This is a question for you. When would we not get a solution?
Do we get a positive?
We get a positive value for this.
Yeah.
So here,
I mean, like negative to be multiplied by each other will be positive. Then we get no solution.
can you be more precise? Which part are you referring to?
That part. I don't know what's called.
This one?
Yeah.
No, I'm talking about. So I want to say something. We would like to say something about this and about that. So that's what we're trying to establish right now. And we want to look at this. So if let's say let's say this square root, whatever is inside the square root, if it's a negative, then that will be problematic, right?
Yeah, that's what I'm.
Yeah. So if this thing, so this is the thing that's inside, if it's negative, then we would have a problem. If it's positive, then we have two solutions. And if it's exactly equal to 0, then we only have one. Is everyone on board with this? Okay, that's a lot of nods. That's I think it's a world record for this SAT session. Lots of nods. I'm happy to see this. And I think, or maybe I claim that this is very sufficient to be able to start tackling the exercises that we have here.
Can we do also exercise about circles?
Circles. Well, let's look for exercises.
These are hard and also can be solved by this.
You want to do them with decimal?
No, they can be solved by this.
Ah, okay. So that's an example of a problem that can be done by decimal. Okay, that's a good suggestion. You can do circle type of problems, but I need to locate the difficult problems first. I think they are. So how many questions in total? So it should be the last 25. This is the first difficult question. Would you like to do this, or would you like to proceed like Wissam is discussing? Would you like to do circle problems?
Look up to.
You want to do
Can we
circle
do-
problems?
Can we do both?
We can do both, but I'm asking what you can start, what you would like to start with.
Doesn't matter.
We can start with this. This is not too bad, and then we can move on to the next one. Will be a circle problem. I'm not sure what you mean by this. I have some idea, so I'll just move over the questions and then it's good. Or you can also open Moodle. The hard quiz is on there, and you can just try to locate a similar question which you cannot approach using decimals. Hope you will allow me to go do something really quickly here. So I just would like to circle back to the part where we were talking about 2 times 2 systems of linear equations. So this is the exact same thing, but the difference is that we don't have linear equations in this case. If I look at all the cases I can get, and this is a generalization of the linear case. Now, when I talk about this, I don't need to deal with linear functions. So I can have, let's say, a parabola.
So actually, it's like that's something
Yes.
like I'm saying it's like 2y. You mean that 2y is equals 4.5. So does that mean that x power 2? That means that x is equal like 0.85 or
So y is equal to 2y is equal to 4.5.
Yeah.
Then you're saying that x is equal to?
What do you mean, like, we divided it to divide 4.5. It's equals like 2.25. So what I'm saying that for x that means that x is equal 2.5.
So this is correct, but it doesn't mean that x is 2.5.
X is 0.25.
No, I don't see. I mean, I don't see any.
Okay, maybe you can put the y is equal with the y, we can look at 2.25, it's equal to minus 4x, or 2 plus bx.
So this is the first thing you did. What do you want to do?
To put like remove the y, put 2.25, it's equal like minus 4x power of 2 plus bx. So
So that's because
yes,
minus 4y squared plus bx is also equal to y.
yeah,
You would like them to match.
that's what I'm saying.
Oh, okay, that's good. That's a good approach to it. Okay, so now you have what? You have minus 4x squared plus bx is equal to 2.25, right?
Yes.
So this is the case. Can you solve this equation? And you should be able to.
Yes, it's like all we're gonna do, we should find the value of b. So they want us, they want actually be the consequence. So I would like to do like as a 4x. I would do it like 4 divided by 4. Move the power of 2x power of 2. 2.25 divided 4 to 4 divided 4 2. So all we're gonna have is like 2.55
Divided by 4.
divided by 4, and 4x power of 2 divided by 4 2. So we remove the 4 and the 4 here, and 2.25 divided by 4 is equal to what?
I'm not sure. It'll give you some number, but I have a better direction to go into. Maybe Ali wants to say something.
We can use that for
Quadratic formula. Good idea, but I need to set it up.
we just gonna make
Yeah, that's very good. So I need to take away 2.25 from both sides. And if I do this, here I get a 0. I get 0 is equal to minus 4x squared plus bx minus 2.25. And guess what? So at least for this part, I'll move down to below. Not needed right now. And we are here. So this is true. And we can now summon the quadratic formula, which is this, to find the roots. Because the roots are the values of x that make the function equal to 0. So that should be a good approach. Can you help me plug in the values? So first up,
so A is gonna minus 4,
minus 4.
and we're gonna be this B, this is the constant, and C is gonna be minus 2.
Okay, so let's see where this takes us, yeah?
Yes.
B is B, B squared is B squared.
Minus 4 multiplied by minus 4 multiplied by minus 2.25.
I'm giving myself a little space for some reason. Yeah, now I have more space. Okay, and then dividing by 2a, right?
Yeah, it's positive.
So a is equal to minus 4, so 2 times minus 4.
Minus 8.
Maybe I can write it as minus 8. And for the value inside, perhaps I should compute it as well. So 4 times minus 4 times minus 2.25 is 36. 36. Maybe I should leave it as this and then below it I write the following. Here I get minus 36, right? And below I get divided by 8.
B should be 6.
Why should B be 6?
Yeah, we said that one solution, so one solution that means it's gonna be 0. So it should be
Exactly. So we're looking for exactly 1 point. And exactly 1 point means that it's that this square root, we usually call it the discriminant, is equal to 0. So if we choose the B that makes this equal to 0, then I will get only one solution. But if I want to get two solutions, I would take the value under the square root to be positive. If I want no solutions, I will take the value under the square root to be negative. And if I want it to be exactly 1 point, then my B should be equal to 6. Because I would like
in this case, we want to decide like the value of B if we want like more than one solution. This time means for one solution, we can decide the value of B, right? Like to choose.
yeah, so you can play with B and you can choose the correct value. So let's say I give you multiple choices and I tell you which value of B will give you no solutions. Then you need to choose the value of B which is greater than 6. Sorry, less than 6, because then it will give you a negative. And I don't think so. Well, I think so. You can, but you have to use a parameter. You have to use a slider. Exactly.
So writing the question exactly intersected one point and it's positive. So the idea.
So you got the answer using Desmos.
Here it is.
Okay, that's good. You could also do that. But if you also know this, you could also do it the standard. So it's nice to have many things in your skill set. By the way, I mean, if we look at this, but the answer could also be minus 6. So you need to be careful. But just because they ask for a positive constant, is the answer going to be 6? And maybe I will not talk about this. I think it is fine. Now, have you found a question on circular?
No, but it's all system equation. The question that you need to be familiar with the equation of a circle.
This looks. I mean, if you would like, we can construct a question, make up a question. But I'm not sure. How would you like this question to be?
Equation of the circle and find the radius and the midpoint, I think so.
Okay, so let's take a short break.
Yeah, for example, like this one.
Amazing. Bless you. Here I have a question. Let's see. And then there are some choices, but I'm not interested in this. So the general equation of the circle looks like this. where this is a circle centered at A, B with radius R. Let me give you an example. The simplest one is something called the unit circle. So welcome back. We're freestyling a little bit. So x squared plus y squared is equal to 1. Now, a question for you. Question for you. Now, this is the definition of the graph of the circle. So, can you tell me what where the circle x squared plus y squared equals to 1 is centered at? So x squared plus y squared is equal to 1.
Shouldn't the answer be 45?
45. I'm not answering the question. I'm asking you.
Oh,
If you look at x squared minus y squared is equal to r, x squared plus y squared is equal to r squared. Let's say 1. So let's say x squared plus y squared is equal to 1. Where should this circle be centered at, and what should its radius be? Exactly. Is this clear for everyone else? So Flavia just said that, if you put in 0 here and 0 there, and 1 there, then you get this equation. So that's just a simple example. You can also verify this using the graph. Yeah. This does not look pleasant. Okay, maybe now it looks a little bit more like the circle. The green one. So that's something. Now we would like to, in order to find the radius, you need to bring this function into that form. That is really the end goal. So we go back here and we would like to have x in something that is compact. So you would like to have x minus something squared and y minus something squared. Now here's the good trick that we can learn something from. And it goes as follows. So first off, we would like to have, if you want to write x minus a squared, yeah, you need to complete the square. And maybe we explain what this means now. So first off, I just would like to take a common factor here. I see all terms have a factor of 2. I hope that's okay if I do this. And the reason I do this will be clear in a moment. So I just want to deal with this part. I have this set up. And I would like to be able to complete the square. How do I complete the square? Completing the square is a very simple idea. It says that if you have a say you have x plus a all squared. Well, I mean, in our very specific case, we have x minus a all squared. So we might as well just expand this. This would give us x squared minus 2 times a times x plus a squared, correct? If I do the same thing for y minus a squared, I would get y minus b in this case. I would get y squared minus 2 times b times x plus b squared. This is just the quadratic expansion. I hope everybody's familiar with this. If it's not, I can show what to do. So we want to have this, but we have this. So we go one step into the direction of this expression. We can start comparing. So what I would like to do is I would like to deal with the case of y squared minus y squared plus y separately, and deal with the case of x squared minus 3x separately, and see how we can complete the square for each one of them. And we can compare the coefficients. So here x squared, coefficients are 1, this is fine. But then if you would like to bring this to the nice format, then you would like to have 2a be exactly the same as 3. Then probably you should choose your a to be 3 over 2, so that when you do the expansion, you get your 3. You see where this is coming from? This is very important, because I feel like we're struggling with this. This is important. And so I hope you don't mind if I write this as x squared minus 1.5 times 2 times x. Okay? So all this time, I'm just comparing terms. Just comparing. 2 times 1.5 times x. But then I need my a squared. In this case, if this is twice of a, then probably a is 1.5. This is like a is equal to 1.5. Then
So from where we got x to the square root minus 3x?
so this is, I'm just doing the problem separately. And so this is the big expression. I factored out a 2, and now we're learning how to complete the square.
Okay, so we got part from origin, which is x squared plus y squared plus y. Separately, then
Yeah, we're dealing with the cases separately. Yes, exactly.
okay.
So we will deal with the cases separately, because we would like to substitute for these terms. We put something that's equivalent. Now, here's the trick. We are here, and we want the a squared. We really want the a squared. A is equal to 1.5 squared. Then I probably should add 1.5 squared. Then that would be amazing. It would be amazing to just have 1.5 squared. Then I can write this as x and minus 1.5 all squared, right? That's good. But the thing is, I don't have a 1.5 squared. I only have 0. So if I add a 1.5 squared, I need to take it away again. So this is what it means to complete the square. You complete it by adding the part that you need to have this compact expression. And this is completely fine, because this whole thing is equal to 0.
Just a minute.
I don't divide by 2. So what I'm trying to do is at the start I had x squared minus 3x. So I want to bring it to the same form. So instead of 3x, I write 2 times 1.5 times x. And when I do this, I've already located my a. What would the value of a be in this case?
1.5.
1.5, right? Then I know which value I need to add to get the square. So I do that. And this expression gives me the square. But I still need to take away the exact same amount.
Why?
Because I cannot just add a constant out of thin air, but I can add a 0 out of thin air. So it's a trick. This is the trick called adding 0. There's also the trick of multiplying by 1.
But how did the square stay?
What do you mean? So I've not completed, so I've not written this full expression. So it's missing this value. This is what it's missing. Maybe I will put a small. So this part is equal to x minus 1.5 squared. Is this good for everyone?
Then the example without decimal points.
Without what?
Decimal,
Small points.
can we use whole numbers in another example?
I mean, you could write this as 3/2. You know, 1.5 is 3/2. It's just. They're just numbers, you know. And actually, I have an exercise for you now. That is the following. So, can you bring this y squared plus y to the square form? So the first thing you need to do is to find b. Find the right value for b by comparing the coefficients. The second thing you need to do, this is an exercise for you now. The second thing is add 0. We add 0 is equal to b squared minus b squared. Is this good, or would you like me to walk you through it? Walk you through it. So, y squared plus y. And what's this is y. Why did I write x? It's y. My apologies. So, and what's the coefficient of y here?
0.
Here,
1.
1. 1. And what's the coefficient of y there? It's minus 2b. So minus of 2b is equal to 1. I can write this explicitly if I'm confused. So minus 2b should be equal to 1. Then what should be my value of b? Minus half. Okay, now if this is b, then what is b squared equal to?
Minus half the square.
Minus half squared is 1/4. So here's what I write down. So I write this 1, but I write this exact same expression as the following. I write y squared minus negative half y. Okay, negative half times 2 times y, because I would like it to match this format. and then I add. Okay, let's not add. That's the first thing I do. Is this fine? You know, because
You can't make it just plus y squared plus.
I mean, it was like this. It was y squared plus 1, but I needed to be, I need to be in the form y minus v squared. So I need y squared minus 2by plus v squared. So I do this manipulation. And then the final thing I need to do, I need to add 0. So how do I add 0? What quantity should I add? Almost. Y. So we would like to add v squared to get this, correct?
1/4.
So we add 1/4. But we cannot just add 1/4
Also
from
add another minus 1.
exactly, because we cannot just add 1/4 from thin air. So we add 0. So here we add 0. But at the same time, this is the square. So this is y minus what squared?
What?
So I'll ask this again. You can compare with this. So we've satisfied everything on the left. So on the right. So this should be the value on the left.
Y minus y. What minus half?
Minus negative half.
Yeah, negative.
Because b is equal to negative half. So it's y minus negative half. So I write this down. I write y minus negative half squared plus, okay, not plus, minus 1/4. I added 1/4. Oh, sorry, this is a mistake. Should extend on. And then I take away 1/4. So this is an equivalent expression for y squared plus y. Y squared plus y can be written like this. And then we're almost done, because this was my original expression. Just give me a moment. This was my original expression. So this is going to be equal to, I hope you don't mind if I divide by 2 on both sides. This is equal to 45 divided by 2. Now I can replace x squared minus 3x with this, right? And I can replace y squared plus y with that thing. So I replaced y squared plus y with this thing here. I did the same thing for x squared minus 3x. Remember, we're adding these two values. Then this is equal to 45/2. Now let's compare to what we had above. Now y minus negative half, you can just write as y plus half. And if you would like to compare it with this, then, oh, not this one, that one. Then what are we missing? So here we have x minus 8 squared. Here we have y
positive
minus v squared. And here we have the radius. But this is not the radius, because we have these. So probably we should add them. Probably we should add them to both sides. And then we would get our answer. So to conclude, we add 1/4 and add, we need to take away a fourth and add 3/2 squared. So you get the following. You get this. Plus that is equal to this, but you need to take away four. You need to take away. Did we take away a fourth or did we add one? We took away fourth, and here we took away 3/2. Yes, so we're taking away that, so we need to add both of these values. That was a small error on my side. So this on the right is the value of r squared. So if you take the square root of this thing, then you should be able to find the value for r. Now, would you like to compute this? So it's this value. Just to conclude, so we've been doing this problem for some time. It would be nice to get an answer. You got 4
What we should take an answer.
for this one.
Five?
Looks like it. Is it 5? Is it really 5?
7.2.
7.2.
It's
It's fine.
It's 5, really?
This one.
No way.
Yeah. This.
So 3/2 squared. But I think you can also use decimals.
Yeah.
I thought you said you could.
Because sometimes because we cannot, I don't know how. I forgot which case.
There's this finding the distance.
But if you know how to complete the square, then yes, the answer is 5. And I think it's very nice how out of all of this chaos, you get a 5 in the end. So that was good. We now know how to complete the square. We've done also an exercise, but we're a bit short on the other ones. So you probably need to make up for this by doing the exercises on Moodle. I've uploaded them. And you can always utilize the question space, which is here. So here, this is a space on Teams. You can post your questions and concerns. You should have many because I've uploaded, just for this skill, I've uploaded 73 questions, maybe more or less. So that's all I wanted to say. Thank you very much for joining. It's been an absolute pleasure. Do you have questions? Okay, then maybe I should end it here.